Hello again, Aid of AG Engineering, welcome back. I've mentioned in previous videos about doing a threaded test ring for this this exhaust thread repair project I'm looking at. I got a tap which was supposed to be a 54mm, but it's actually I think a 2 1/8 by 16 TPI with form 1. I've come to look at it. It's been shortened at some time in the past and had some new flats machined on it, as we can see here. So it's not a square, it's just a couple of flats, which is fine, not a great problem. But it was straight on the back here. It didn't have a centre point, which I'm going to need for location. So I've already done this little job. I've drilled a hole up there for a centre to fit into. I've had to do it with a carbide drill, and the only carbide drill I've got is a 3mm one. But it seems to locate a centre. Okay, that'll do for. It's only to keep it in line as I'm hand tapping, so that'll do fine. You can see from the setup I've got it in the 4-jaw chuck on the small lathe, and just the steady rest to support it while I drilled it. I've clocked it up on this face to make sure we're in the middle. So I'll get this out of here, and I'll see you back in the workshop in a moment. Hello, and we're back in the workshop again. The tap that you saw in the lathe in the garage a moment ago is that one with it's got a guide stub, we'll call it, to put a guide bushing on as well. If need be, I can cut that off later on if we don't need it, or if it doesn't get in the way, I'll leave it there. I'm going to make a threaded test ring from this piece of stock here. I'll get it set up in the big lathe and bore it to size. What I should probably do, rather than trying to go straight in with this because it's a bottoming tap, I'll start off by internal threading, and we'll get the thread well on the way with this, and probably just finish up with running the tap through to make sure it's right at the end. And once I've got that, I can start on doing either a test plug similar to the internal thread one that we made earlier, or I'll go straight in and start doing a piece of the phosphor bronze bar and see what that comes out like. So I'll go and get set up on the larger lathe in a moment. I noticed on the previous video the sound was muffly and terrible. I'd got the camera in the waterproof case that comes with them with the open back, and it still wasn't brilliant. So I've got it set up at this moment in what we call a skeleton case, which gives makes the microphones open and accessible. So we'll see what the sound's like with this one. I have got an external mic on the way from China, of all places, and we'll play with that when that one gets here as well. So I'll see you back on the lathe behind me in just a moment. Here we are, set up in the 4-jaw, just getting it running true on the face to start with. that front face through set up for doing the bore. Nearly there. It's about as close I'm going to get that one. I've just been playing about with it off camera. I'm not too concerned. All that'll do. I'll just rough out. Got to take it to approximately 2 inches. So I'll just rough out the bore very quickly. I'll get close to where we need to be, then we'll start looking at the digital readout. It's actually quite a bit of tough stuff. It's a bit off a sprocket. I'm modifying it's the boss off the back of the sprocket. Under the steel. Come back when we're closer. Right, I've changed tools. I'm out to about 1 inch with the smaller boring bar. I've just swapped over and touched off and just took a light skim with this tool here. Always try and use the biggest boring bar that you can to minimise any springing. I'll just go through the method I'm using for setting up the digital readout while we're at this point here. So with that bore there, if we go in and measure, not ideal with calipers, but until we get closer to the size we need, this will be fine. So zero that, yeah. And 1 inch and 18, about 1 inch 18th thou, 1 inch 17.5 at that point. So if we go to the digital readout now, just reposition the camera. So here we are at the digital readout. 1 inch 18 thou, so 509 thou is half of that. So ignoring the y-axis, we're not bothered about that one. If we zero the x-axis at that point, if we enter into the x-axis, half of our required diameter, or half of the diameter that we've got at the moment, so put the radius in. So if we go 0.509 into the x-axis as a measurement, which is what we've just took from the work, and we go, sorry, enter that, we're now at 1 inch and just a tad under 18 thou. So now we've got a direct reading of what the diameter is that we're turning. So as I turn the cross slide out here on the lathe, what I'm seeing on the display is what I'm turning on the actual work. So we're at 1 inch and 18 thou. So let's go back to the work again. We're all back at the work, having set the digital read out to 1 inch and 18 thou. And if we go at that, we're just taking ever such a light skim off that, almost a spring cut. So as I now move out with the cross slide, what I'm reading on the digital readout is what my hole diameter will end up as. As I get closer to the finished dimension, I'll still check with bore gauges, T gauges, snap gauges, whatever you want to call them, or whatever you want to use. But it's much easier to do a bit of work to size with a direct reading just in front of you. Well, that's how I'm using the digital readout. So 50 thou cut. This is a very high carbon sprocket steel I'm machining here. Probably not the ideal. Okay folks, can you see that hopefully? This is the calculation for the size I need for the tapping size for the tap I'm using, or for the thread cutting procedure. It's for calculating tapping drill sizes for with threads. I can't remember where I got it from, but there's what we're aiming for: 2 inches and 45 thou. There's a little note at the bottom of the factors that you use for calculating this. For Whitworth threads, you're using 1.28 in the calculation for 55° threads, and for UNC threads use for 60° threads use 1.3 in the calculation. So pause the video and take a note of that if you need to. Right, we'll get back to the turning part. That's where I'm up to so far. So we use the usual sort of bore measuring instrument here. I'm up to 1996.5, 63, 1996. So now we'll take our reading from the micrometer, 1996, and we'll put that into the the x-axis, so we're already zeroed and cleared there. So 1.996, enter that. 19959, it's rounded it to, so we're ready to go again and carry on boring to our tapping drill size. Last cut on this one for our tapping drill size. Okay, we're ready for screw cutting here. The screw cutting gearbox is set up to 16 threads per inch. There, we're on low speed, 54 RPM. We're on English on the lever there. Thread chasing dial is engaged, the lead screw is cleaned, and I've touched off, and we're at the start, ready to go. Right, the battery's going flat on the camera, so I'm just going to have to go and change the battery. We'll put a little bit of oil in there. I'm cutting now with high speed steel tooling, not carbide, and so this is a pretty tough bit of steel. So I'm on a 0 point there. My tools squared up to the work, and I've got the compound slide over at sort of 29 degrees or so. So I'll put a little bit of cut on. And I'll be watching the thread dial. We're on an even number of threads, so I'll go either 2 or 4 on the threading dial for engagement. Also 0 the cross slide, just an extra caution, as well as a digital readout. And let's see what happens. I'm watching the chasing dial, the threading dial coming round. There's coming out to be 2 mark here on the dial. And we're in. I was watching for the tool to come out of the back. Slight problem. Slight clearance problem here. Right, I've got a snag. The corner of the compound slide is going to start, it's just slightly started to hit the chuck jaws. I haven't got a long enough threading tool to extend it out anymore. And what I may have to do is not set the compound over at that angle. I'll come back to you when I've just reset up. Okay, take 2. I've reset my compound and put the tool in square in, so I'm not on the putting the depth of cut on with the compound now. I'll just put it on with the cross slide. So I've already touched off, just zero my reference point, and I'll put a couple of thou on. Again, move that up. Wait till my the mark comes round the floor, and we should still be in. No, we won't be in the same place. Fortunately, I've not done much of a pass, so we'll start again. Go up to the floor. Fire. Okay, we're back in position. I'll start again with the cut. I'm just coming up to my 4 mark on the thread chasing dial. Gauge it there. This time back in with the compound, sorry, with the cross slide, back out. Stop it. Just do a quick check of the setting there. Yep, that looks good. $16. D8. Okay, carry on. Bit more on. Top, ready. Mark to come round. Back in past my 0, back out, back on the depth of cut, missed it, go. Zero, out, just a couple of thou cut on each time, just wait for the mark to come round again. Well, this is quite tough stuff to cut as well. I'm also going straight in with the cutting tool with this setup, not in at a 30-degree angle, so I'm taking off both sides of the cut at the same time. Pull around. And we'll continue like that till I get close. Bring you back in a moment. There we go. We're there. Just by hand. No shaking that. I'm happy with that. Need to put a bit of a chamfer on. Just clean that first thread up a little. Right, there we go. One of the reasons I wanted to actually thread cut this rather than tap it through, I was originally thinking of tapping it, was so I can make it slightly oversized on the threads. So this will be a test ring for the bronze inserts, and if they screw into this ring, then there'll be a tight thread on the tapped hole in the head. So it's a little bit oversized, a little bit sloppy on these threads to give us an interference fit between the two threads, or a good tight fit, so that things don't come loose. So there's the test ring. There's the test ring done, and ready to go. I'll start looking at the bronze inserts next. I don't know whether to try and do them fully on the lathe with the piece of material held in the chuck, or whether to cut them off into slices and thread them internally and then screw them onto this part, then hold that in the forge or trig up in the forge or and cut the external threads onto them. It's a matter of experimenting, I suppose. I'll try one and see what it turns out like. I think if one was screwed onto there and that's turning, you're turning against the rotation of the direction it's screwing on, so it should tighten itself up rather than come flying off, I hope. So the next part, the next episode, I'll get the piece of bronze bar ready and get that trued up in the chuck. I've got that over here somewhere. There we are. Well, that's that's around about 54mm anyway, and that just fits on there just nicely in that stock bar, so very little if anything to come off the outside, very slight amount, and see what we can do. I'll have a little think and keep your eye out for what I come up with. So, as ever, thanks for watching, thanks for subscribing. Hope you're enjoying this little series, and I hope, fingers crossed, it works out how I'm kind of planning it. So thanks again. Bye for now.